So session 2. So we are directly entering into deep learning. So image classification using CNN. Image classification using CNN. Convolution neural network. Directly we are entering into image processing. It applicable for medical image diagnosis or all set of images. So image classification using convolution neural network. A small intro. So convolution neural network. So convolution neural network, which is basically a combination of convolution. So as a name itself, it's a convolution neural network. So it is a combination of convolution, which followed by the basic operation like feature maps, subsampling, image features, then dense layer of NN. So this is a base of convolution neural network. So it's purely the combination of convolution and neural network. So it's mapped, the theme was to extract a feature from an image and then use the dense layer of NN to categorize whether it's a dog or cat. So which categorize a image. That's a theme of convolution neural network. There are wide variety of applications for this CNN. So which applicable for image recognition, then video recognition, object detection, object identification, NLP. So there are wide variety of areas. This CNN plays a vital role. So normally deep learning, there are two major kind. The first one, which is called as convolution neural network. The second theme, which is named as recurrent neural network. So this is the first theme, convolution neural network. So the major theme was major theme of deep learning or convolution neural network to act a machine or to act a model like a human brain. So artificial neural network, it's a base of convolution neural network. So we are passing an input signal. So based on our neuron, it can process the data and then return the output signal. So CNN, convolution neural network. I'm giving a very small example. So this is a small pictorial representation. So this pictorial representation, this image which represent a number 9, the image which represent a number 9. So here there is a number 1, 1, and 1, 1, and 1. So all those locations where the number 9 present, all these pixels are marked as 1. All other pixels are marked as -1. So small pictorial representation, that is 5 cross, I think 7. So 5 cross 7 image. In that image, I am representing a number 9. Here, where the number 9 is present, all those pixels are marked as 1, remaining all the pixels which marked as -1. So now, so the same. So this is a pattern where 9 present. This is a pattern where 9 present. So all the other location which marked as -1. Now, so if the number 9 which present in the leftmost corner of an image, location shifted. So a location of a 9 was shifted into leftmost position. So in that case, these set of pixels are marked as 1, other pixels are marked as -1. Similar way, if the 9 which represented in the center of an image, it's like that. But these two things are equal? No. So if location shifted, entirely the pixel variation was done. So how to classify an image or how to classify a letter? So that's a theme. Then now, each and everyone, they are writing letters in a different manner. So writing style was modified. So text recognition or number recognition or number plate identification. So each and everyone writing a letter in a different format. So here the number 9 which written in some lean case in a different model. So there is a variation. So here the numbers are plotted in a different manner, but actual presentation is this. Then think about this variation. So how to solve these issues? Then to handle variety in digits. So this is a thickness, very lean. It's a bended one. This is the representation. So if a handle for wide variety, we can use simple ANN. So handle a wide variety of a same digit. You can go for artificial neural network. So neuron was trained, whether it's placed left or right, whether it's lean or hard, that's not a problem. Automatically CNN or ANN, which handle the same. Automatically ANN, which handle the same. Now, this is an example. Please listen carefully. This is one of the excellent example of convolution neural network. So here, the number 2 is a input. Number 2 is a input. So number 2, which represented inside the image like this. So this is the pixels. Number 2, which represented in 7 cross 7 digit. Number 2, which represented in 7 cross 7 digit. Sorry. So you are flattening the image. So you are writing all the pixels. So right here. Then next you can write all this. So next you can write all those things. So next you can write all those things. Similar way, you can write the entire 7 cross 7 image into flatten mode. This is called as flatten mode. You can represent it here. Now, so totally 49. So you can represent it as 49 cross 49 neurons. So similar way, which need 49 cross 10 hidden cells. So now which map do. So now you can pass the input into neural network. So which can pass via hidden layers with a adjusted weight value. Now it says this number is equivalent to 0 for the possibility of 29%. If the number is equivalent to 1 for the possibility of 7%. If the number is equivalent to 2 for the possibility of 92%. If the number is equivalent to 3 for the possibility of 8%. If the number is equivalent to 4 for the possibility of 0.1%. If the number is equivalent to 9 for the possibility of 4.3%. Now think about situation. This is 92% equivalent. So the number is 2. So the number which mapped into neural networks for the neurons, then the weight value was adjusted. If it's which one is maximum, the 2 is maximum equivalent to the digit. So it's 92% equivalent. So the image which was mapped to the digit 2, it mapped with number 2. So now the same thing, I have mapped to an image. So this is for digit. So this is an image which will be called as cola. So image which will be named as cola. The size of the image was something 1920 pixel cross 1080 pixels. So the color which is RGB, so which represented in 3 layers, R, G, and P. So the first layer, which comprising of even a digit, even a single digit of 7 cross 7, sorry, 5 cross 7 pixel, sorry, 7 cross 7, that is 49, which mapped into 49 cross 49. But here, that will be leads to 6 million. Single image, which mapped into 6 million neuron. In the hidden layer, which leads to 4 million neuron for hidden layers. First layer for 6 million, 4 million for hidden layer. So the weight between the input and hidden layer, 6 million into 4 million. Yeah, too much. 24 million. So how to manage this? So in that too much of computation, the artificial neural network which fails. If it's normal digit recognition, in that case, a normal neural networks which works fine. If we are for larger computation, if we are processing for an image, in that case, which too much computation, so you can go for convolution neural network. So if it's simple image with 7 cross 7 pixels with a simpler matrix representation, in that case, artificial neural network is enough. If the image size was larger and RGB layers too, too much computation. Because of that, you can go for convolution neural network. Now, it can identify like this. So, normally a baby can identify an object like this, similar way. It can view the eye, whether it's cola eye or not. Yes, it's cola eye. It can map nose, whether it's cola nose or not. Yes, cola nose. It can map ear and whether it's cola's ears or not. Yes. Now, it can map hand, then whether it's cola's hand or not. It can map leg and whether it's cola's leg or not. If it's cola's eye, if it's cola's nose, if it's cola's ears, then that object which is called as cola's head. The eye is equivalent to cola's eye. It's 90% equivalent. The nose was 95% equivalent to cola's. The ears was something 89% equivalent to cola's. So eyes, nose, and ears are equal. So this is cola's head. Then cola's hand and cola's leg. Then it's called as cola's body. So this is mapped with cola's body. Then, so it's cola's head, it's cola's body. Then you can say the object is cola. Then you can say the object is cola. So automatically you can pass the image, system can classify it and then take whether it's a cola or not. And then it can take whether it's cola or not. So this is what convolution neural network work. It can classify the object into multiple features and then combine it into next level features and then at last merge into whether the object is cola or not. So this convolution neural network is properly fit for object recognition as well as image classification. So this is another example for a digit 9. For a digit 9. So if the digit is 9, so this is a symbol, this is a symbol, this is a symbol, combine that, there is a loopy pattern. There is a loopy circle pattern in the top. Then line and line. Yes, that's a vertical line in the middle. Then a diagonal line at the bottom. So if an image which having a loopy circle pattern at the top, then vertical line pattern at the middle and diagonal line pattern at the bottom, then the image is a number 9. So image which having a loopy circle pattern at the top, vertical line pattern at the middle and diagonal line pattern at the bottom, then the image is number 9. Then the image which represented as number 9. So now view that the loopy pattern. So here the same number 9 in the first example. So all those where the digits are present, it will be represented in 1. All other cases are represented in -1. So where the numbers are present, it will be represented in 1. All other representation which will be represented by -1. So now the loopy circle pattern. So loopy circle pattern, that's a filter. You can create a 3x3 filter. All the things are 1. In the middle only you can change it into -1. That's called as loopy circle pattern. Loopy circle pattern. Then similar way, vertical filter pattern. If all the 3 sets are 1, it's called as vertical filter. If all the diagonal 3 are 1, it's called as diagonal line filter. So you can create 3 filters for the, you can create 3 filters. The first one for loopy filter for top of the number 9 identification. The second one for vertical line filter, which is used for middle of the number 9 identification. Then bottom diagonal identification, which used for bottom of the number 9. So you can use 3 filter to identify whether it's number 9 or not. So now the filter. I hope everyone is very familiar about this convolution and filtering operation. Anyway, I will explain soon. This is my image number 9. Then this is my filter. So loopy filter. So loopy pattern, center only -1. This is for loopy circle filter. Now you are finding applying the same. So now I am applying this filter here. So 1 into -1, 1 into 1, 1 into 1, -1 into 1, 1 into -1, -1 into 1, -1 into 1, 1 into 1, and 1 into 1. You have multiply all those and then perform summation, which can return the result -1. Then total number of pixels in the filter is 9. So -1 divided by 9, the value is -0.11. The value is -0.11. Sorry. So if you are representing a loopy circle pattern, so then the values, all those values are 1. Then you can multiply those things and then perform summation. You can get the value 0.11, -0.11. Now next, I will apply the pattern. I will apply the filter, move from here to this. I have applied the filter and fill the value here. Yes. Now I will same way multiply everything and then add those things, the value as 1. So then move the filter next, 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 next. So filter was applied to all those location and fill. This is called as feature map. This is called as feature map. This feature map would choose to identify the loopy circle pattern is present or not. If an image contain loopy circle pattern or not. This is a theme of feature map identification. Now, if it's number 9, the loopy pattern which is placed at the top. If it's number 6, the loopy pattern which present at the bottom. If a number which having 2 loopy pattern, the number is 8. So it's very easy for recognizing numbers. So system automatically train this and then find a loopy pattern is present. Then it's number 9, or if it's placed in bottom, it's number 6. If it's placed in 2 location, it's number 8, something like this. Now, if it's 96, 1 at bottom, 1 at top. So there is first level of feature map was done. Filters are nothing but the feature detector. So the theme of filters in convolution neural network is it's used to detect features. So filters used in convolution neural network we choose to detect features, feature map. So now for a cola image, that's for digit recognition. Now I'm entering into for cola image. So here the cola which comprising of 2 eyes. So 1 and 2. So the loopy pattern we choose to identify whether it's cola eye or not. Here the eye was present in different location. This second image, the eye was present in different location. The third case, there are multiple number of colas in that image. So there are something the last cola which shows only 1 eye in the viewer side. So totally there are 5 eyes was displayed in the image. So there are several location variation and multiple image variation which is available. But our trained deep learning convolution neural network. So our trained deep learning convolution neural network which plays a vital role and detect an image. So now this is a pattern for hand identification. This is a pattern for hand identification. So you can apply this filter pattern, hand detector, so it can present whether the hand is present in that location. So this filter was applied in the image and then you can find the hand filter pattern, hand is present in that image. Now, so first one, whether the image contain loopy pattern or not, Then this was loopy pattern. So in the top of the image, the loopy pattern is present. At the top of the image, the loopy pattern was present. Now the vertical line detector. So the loopy pattern, you can use this 3x3 filter. If you are finding vertical, the middle of the number 9. So in that case, you can apply vertical line detector. In that case, you can apply vertical line detector. So in vertical line detector, so you can apply this filter on multiple location, and then at last you can get one here. So there is a vertical line is available on that image. Now this is a last one, that is diagonal line. So here the diagonal line which is present at the bottom. So if a image which comprising of top there is a loopy pattern, middle there is a vertical line pattern, in the bottom there is a diagonal line pattern. So the combination of these three which makes the convolution neural network to identify the image which represent a number 9. The image which represent number 9. So loopy pattern at the top, vertical line pattern at the middle, and diagonal line pattern at the bottom. So we choose to identify the image is number 9. We choose to say the image is number 9. So it creates for image, you can multiply it with 3 filters. Filter 1, this is for vertical line filter. This is for diagonal filter. This is for loopy filter. So loopy filter, diagonal filter, and vertical line filter. You can apply these 3 filter. You can get 3 feature map. You can get 3 feature map. The loopy pattern at the top, diagonal pattern at the bottom, and then vertical line pattern at the middle. So applying 3 filters to the image, you can get 3 feature map. 3 feature map. Then, so here you can apply eye pattern. So eye was present. You can apply nose pattern. Nose was present. You can apply ear pattern. There is filter. Then ear was present. So that is a 3 feature map. One which identify whether eye is present or not. The second feature map which identify nose present or not. The third feature map which identify ears present or not. For combining all the 3 feature maps, you can identify a cola having head at the top. So eyes was present, nose was present, ears was present. So combining all the 3 filters, you can get 3 feature map. So combining the 3 feature map, you can get the result as new feature map for cola's head was present. Now, this is for cola's head was present. Same way I have applied for whether cola's hand was present or not. Then cola's leg was present or not. So if cola's hand was present at the top and cola's legs was present at the bottom, so it says that the cola's body was present in that image. So this was cola's body. So if an image which comprising of cola's head as well as cola's body, then you can flatten that image. So a image which comprising of head and body, then you can flatten it and then apply it into neural network. Apply it into neural network. So flatten that. This is cola's head. This is cola's body. And then flatten the entire content. And then pass this into neural network with the adjusted weight value. Then the neural network was trained. Then it says whether is this cola or not. So based on this feature map. So always machine learning algorithm, you are responsible for creating features and then passing it to variable. Here system can automatically identify the feature map and then pass it into neural network and then says whether is this cola or not. Whether is this cola or not. This is a method for identifying object detection and object recognition using convolution neural network. So this entire process, which is called as feature extraction, this neural network, this process which is called as image classification. So this entire process which is called as feature extraction, then second stage which is called as classification. Now, the step number 1 for applying filter, that is convolution. So applying filter for identifying convolution. So this is a convolution. This is for feature map. In that feature map, you can perform the basic activity which is named as Relu. So basic activity Relu. So view the graph. This is for line and this. So if the number is less than 0, that is -1 or negative numbers, so it's in 0. So all the negative numbers are changed into 0. All the positive number taken as it is. So here, this is positive number, this is positive 1, this is positive 1. So all the positive number was taken as it is. If it's negative number, then you can change it into 0. So this is for reducing feature map. So this is very easy for computation. So all the negative value based on this Relu operation, all the negative values are converted into 0. All the positive values are taken as it is. All the positive values are taken as it is. All the negative values which was taken into 0. 1 second. Neural network. So this is a pattern. So first operation was applying pattern. So there are 3 filters for identifying 9. One for loopy circle filter. Second one for vertical line filter. Third one which is named as diagonal line filter. Now you can apply Relu operation. So if the image which comprising of negative value, you can convert it into 0. You can take only the positive value. Now, Relu helps with making a model as non-linear. Relu, which makes the operation as non-linear. Now, first operation for convolution, second operation for Relu. Now the third activity, which is named as pooling, max pool or min pool or average pool. So we choose to reduce the size of the image. So pooling layer, we choose to reduce the size. Please see here. So this is a pool, so which will be mapped into 2 by 2 stride. So here 2 by 2 stride. You can take the maximum value of this 4 element and place it here. You can take this 4 and maximum value you can present here. You can take this 4 and maximum value you can put here. You can take this 4 and put maximum value here. So you can take max pooling to reduce the size. Max pool used for reduce the size. So step 1 for applying filter, that is convolution. Step 2 for something called as Relu. So converting all the negative number into 0, all the positive number as it is. Now step 3 for max pooling. So you can make the image, reduce the size of the image to find max pool or average pool. So this is for max pooling. So you can get this image. So this is for Relu. This is for max pooling. So here you can take the highest value as 1. The highest value as 1. So similar way you can fill it here. So initially you can apply all those 3 filters. Then Relu for removing negative numbers. Max pooling for getting this maximum value. So first applying convolution and Relu to get eye, nose and ears. Second phase of applying convolution and Relu to find head and body of column. So you can apply 2 times. One time for convolution, Relu and pooling. Second time for convolution, Relu and pooling. So based on your image identification or your image classification, you can perform multiple times for convolution and Relu and pooling operation. At last, you can flatten your image and then get the result. So this is for convolution, Relu and pooling activity. So there is no way for thickness. So convolution neural network, which used for image recognition. So It's used to identify the emotion detection too. It's used to identify the emotion detection too. So yes, fine. So now I will entering into a small demo. I'm entering into my CNN. I will reconnect. So this is, sorry, I'm not a robot. So boot. So this is for CNN. So here the step number 1, this is very basic. So step number 1, for import packages for TensorFlow. So import TensorFlow TF, then TensorFlow Keras. You can include the required data set, layers, and models. So from Kera, you can include data set for image classification data set, layers, and models. Then matplotlib.pyplot, you can plot. So for image classification using CNN, you perform import 3 packages, one for TensorFlow, then second for Kera, third for matplotlib. Then step number, I execute the same. Yes, it's executed. Now step number 2, for download a data set. Here, this Colab itself, it comprising of a data set named as CAFAR10. So CAFAR10 data set, which contain 60,000 color images in 10 classes, which comprising of 60,000 color images in 10 classes. So I have download the data set. So dataset.cafar10.load data off. So automatically the data set, train image and train label, test image and test label. So X and Y, X test and Y test. So it can get the value. So this is for loading data set. Then after loading data set, I have scaled it into normalized pattern. So divided by 255. So the scale from 0 to 1. So I execute the same. So step number 1 for import package. Step number 2 for something, download data from dataset. So dataset was loaded. Now step number 3. It comprising of 10 classes. The dataset which comprising of 10 classes. The classes are named as aeroplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. So dataset comprising of 60,000 images varied from these 10 classes. So now I have plot that image in a, just plot that image in a pattern. So just viewing that image. So horse, truck, automobile, cat, etc., etc. So all the images was plotted. Sample set was plotted. Now yes, fine. Data set was ready. Now you can create a convolution base. So you can create the convolution base. So this is for base of convolution. This used for convolution 3D as well as max pooling. Please view here. Model, these lines are common. So model equal to models from this package. Kera. Models from Kera's package. So model equal to models dot sequential pattern. So model dot add convolution 2D of convolution 2D of 32 the pixel image. You can apply the filter of 3x3 filter. The activation as Relu function was applied. The input shape as 32x32 image with RGB color range. So you can apply convolution. You can apply max pooling. Again, you can apply convolution and you can apply max pooling. Again, you can apply convolution. So you can apply n number of times and view the accuracy result. Then you can increase or decrease based on your data set, your requirement. So you can increase convolution or you can decrease convolution max pooling. So average pooling, you can apply several things. Then which one is fit and provide highest accuracy for your data set, you can use for the same. Now I will execute the same. Yes. Now I will print that model summary. Yes, convolution and convolution 2D max pooling convolution. So this was applied. Now, so I can flatten the image and apply 64 cross 10 hidden layers. So this was applied. I will create a summary for just verification. So now neural network was running. Now I will train my model using sparse categorical cross entropy mechanism. So just call that function model.fit of train image, train label for epoch of 10. So it can execute it for 10 times. So this is for first time. So similar way, the process, the trained model was epoch executed for 10 times. So already you can execute it for 500 times for the last experiment. So here which executed for 10 times only. So you can increase epoch value and then it will return a best accuracy result. Then you can go for the same. Now which return a result. Now third round was running. Totally 10 epoch. So now first is completed, second is completed, third is in running stage. So now sixth iteration was running. So you can change your data set if you are having something leaf detection or disease detection for a tree or plant or medical diagnosis, cancer detection. So you can upload any kind of data set for this convolution neural network. Just change the name of the data set or upload your image into Google Drive and then verify it. It can work. So change the number of convolution and number of epoch. So it will be very much helpful for your research. So just for 10 to 15 lines of code, you can change all those data set value. You can get an accurate result. So even how a baby brain or how a human brain can train, similar like that, the system brain can automatically train and then return a result. So that's what the greatest advantage of convolution neural network. So still many of the autonomous cars. So many of the autonomous car, even for blockchain technology, the entire food life cycle. So everything which will be managed via these kind of deep learning methodology. So which plays a vital role in several places. So you can think more and apply it for your research. Then your research was increased into one step ahead. Now the 10 epoch was completed. Now you can evaluate the model for finding the accuracy. So plotting it in a graph. Now the accuracy was plotted in a graph. So here this is a accuracy. Now the accuracy was little bit improved. So print that test accuracy range. So this is for 71% accuracy. So you can change the data set and work it for your research work. So I'm repeat the same again. So step number 1, for import package, you can import TensorFlow and Keras and Matplot library. So TensorFlow for your deep learning process, Keras for dataset layers and models, Matplotlib for plotting in a graph. Step number 2 for loading dataset. Step number 3 for just for viewing images. 4 for proper model creation. 5 for fit the model into flatten, then model into train image and label and running into multiple epoch, then you can get the accuracy result. This is what convolution neural network works. So this is a base. I will explain one more example. Not for recurrent neural network. This is for again for convolution neural network, because convolution neural network which will be helpful for all your research. So I will play other slide. So convolution neural network for fruit image classification, whether the fruit is apple or orange or banana. So fruit image classification using CNN. Now, step number 1, all are very much familiar about step number 1. Step number 1, always importing package. So you can import all the required packages. Step number 2, here, this fruit image data set, which is not available in the fruit image data set, which is not available in Colab. So I have downloaded the data set from Kaggle. This data set which is available in Kaggle. So I download from Kaggle. So initially I will go to Kaggle website, just Google it Kaggle, and then go to Kaggle website. Just Google it. Kaggle. Then go to Kaggle website. Create account. Otherwise, I am already have account. So this is my account. So just click on the account. My account named as K7 Training. Then click on, otherwise you can create a new account. It's completely free. So no problem. So create account. So I will click on account. Then go to bottom. There is a tab for API. You can create a API token. Create new API token. So which will provide a JSON file. Just open it in a notepad. So this is the API for accessing this private data, this Kaggle data set, which comprising of 107 GB. So whatever required you can download. So you can open this JSON file. So this JSON file, which will provide the username of this as well as key of your Kaggle account. So use that username and key. You can log in into Kaggle. I will reconnect. So step number 1 for import package. Step number 1 for create token. So you can upload this token file into your Google Drive. I will upload into my drive /Kaggle folder inside Kaggle.json. So download it, username as well as password JSON file, which will be uploaded into Kaggle folder of my Google Drive. Now, already you are well known about that. Drive.mount content.g drive. Content.not g drive, content.drive. So based on our application, you can mount the drive. Then you can set a content.drive /my drive /Kaggle. So it can download the data set from this drive. So you can use the command unzip, exclamatory mark unzip. Unzip is a command. It's used to extract all those image inside my Kaggle data set. So which will be extracted. So all those fruit images, it will take time around half an hour. So I have already extracted those things. So you can do it. So it can extract it. So entire things are present. So it will take around half an hour time. So already I have downloaded everything. So you can work it during your free time. So step number 1 for importing package. Step number 2 for create a API from Kaggle and then connect it into my Colab. Then step number 3 for just for verification, if needed, just for verification, you can print the file names. So something print os.path directory name comma file name. So we choose to print all those file name. It's not required. Then it will print all the directory name, fruit 30 license and all those file name which is listed here. Now seeing what an image look like. So just viewing the image, you can use the function called as imShowOff. Using matplotlib for show the image from the fruit image data set, you can use the method called as plt.imShowOff. In plt.imShowOff img, we choose to show the image in the data set. The image is apple. So it's used to view the image. The image size was 100 cross 100. and the color range was RGB, so 3 pixels range. Then the image was apple. Now, exploring more images in a data set, just I am plotting it in a label like this: orange, banana, cauliflower, something, watermelon. So it can print everything. So it can print it in a matrix representation. So just for viewing. So step number 1 for import package. Step number 2 for login into Kaggle and create a API and then get that result. Number 1 for import package. Step number 2 for mounting, create a API and mount it to Drive. Then next for exploring it in a data set. Next for if most frequent fruits. So anyway, it's not required. Then total number of classes present. Total number of classes, the total number of features present in that object, total number of different objects present in the data set. So you can print it like this. So now this is a core. So step number 1 for import package, step number 2 for API creation and data set, step number 3 for model. Here, model.sequential, convolution, and Relu and maxpool. Convolution, Relu, and maxpool. Convolution, Relu, and maxpool. Then flatten the image, apply dense, and activation of Relu. If needed, drop out and add the dense layer and activation. This is an entire set for CNN. It's a neural network model. It's an entire set for neural network model. So step number 1 for import package. Step number 2 for download data from dataset. Step number 3 for creating the model. Then step number 4, now you can find categorical cross entropy. That is for loss identification. Categorical cross entropy. So loss identification. So model dot compile loss equal to categorical cross entropy. So you can print the accuracy. So it can print the summary of the same, your convolution neural network model summary was printed. So specifying the epoch. So always for time being, I will give epoch as 10. Actually, real research project is concerned, the epoch as 500. For time being, I will give the epoch as 10. So you can give 500 epoch. Here I am giving epoch for 100. So you can execute for multiple times. Then you can get the excellent result. This is for generating augmented data. So now you can get the exact result. So the model was fit and generate the model. The accuracy was something 0.0182. The accuracy was increased. Epoch 1, epoch 2, etc., etc. So view the accuracy at epoch 100. It's a little bit more. So plot the loss. View the graph. The epoch was less. If epoch was 100, the loss was very less. The loss was very, very less. So automatically you can increase till more number of epoch. Then you can get the accurate result of CNN identification. So this is for accuracy. So if number of epoch was increased, automatically accuracy was increased. So training accuracy as well as validation accuracy. So loss was decreased and accuracy was increased. Automatically a system can perfectly fit for any kind of research. So this is what, so the basic thing. So you can single image prediction for passing a single image. It can automatically predict the image is Raspberry Pi. So Raspberry, sorry. So it can predict the model. So similar way, that's class number is 113 and it's under the classes. So this is what automatically system can classify and return a result. The system can automatically classify and return result. This is a basic methodology for convolution neural network. So deep learning, I'm starts from a base. Deep learning is a basic computer programming model which used to identify what the object is, whether the object is cat or the object is dog. This is what the theme of deep learning. The broader area of computer science was artificial intelligence. Under that, the sub area which is called as machine learning. Under that, the other sub area which is called as neural network. Under that, there is a very narrow area in a technological trend which is called as deep learning. From that deep learning, there are two broad areas. One is convolution neural network. Second one is recurrent neural network. I won't enter into recurrent neural network because convolution neural network is support for all. So I'm explaining two examples on convolution neural network, which basically support with filters with a variety of patterns. Then Relu for removing all those negative values for create a image as non-linear. Then last one that is called as something called as pooling. So we choose to apply max, min, or average pooling for get the exact result. So this is what all those algorithm works. At last, you can make the image into flattened pattern and pass it into neural network. Then you can get the best result with a proper accuracy. So this is what all kind of deep learning algorithm works.